Okay, so is everybody cool with where we are now? Okay, so the yellow part is 15, and the green part is 7 times 15 divided by 2, which is 52.5, yes? Is everybody okay with this concept so far? Now all of you should be figuring it out. It's pretty simple, really, when you think about it, right? What do I do with these two numbers? What do I do with the green and the yellow number? What do I do with the green and the yellow number? Add them to get 67.5, right? So this face is 67.5. Is that the area of the base? Yeah, because that shape repeats, doesn't it? How many times does it repeat? 6. And that gives you an answer of 405 meters cubed, doesn't it? Everybody okay with that? Is everybody okay with that? It's just a prism, right? Is this question any different from this question? Finding the volume of, where was it? Remember when we talked about, come on computer. When we talked about this, and how the volume was all this yellow times 15. Is it the exact same question? Yeah, it is. So, 405. Now, is that the right answer? No. Why?
Because you need to find out how,
I'm only filling the pool 85%, right? So I got to multiply that by 0.85 to get 344.25 meters cubed. Everybody okay with that? That's how much water is going in the pool. How fast is the water going into the pool? 1.8 meters cubed per hour, right? So what do I have to do with that and 1.8? Divide by 1.8 to get 191 hour point something hours. I can't remember what it is. 0.5 exactly? 2.5. Does everybody understand? Now I'll ask you again. Was the math difficult? It was two formulas you already knew. And then doing a percentage that you learned how to do in grade 6, right? So what made this question difficult? Why could I only give out gummy bears thrice? Concept or math? Concept. But was the concept even that difficult? It's a prism. What's every single prism? Area base times height. All right, next question. This one is very tricky. 1 liter is 1,000 centimeters, right? I have meters cubed, don't I? Well, we know, remember when we did 1 meter and 1 meter, and then we changed it to 100 centimeters and 100 centimeters for a square? Well, if I make it a meter cubed, don't I have to multiply it by another 100? So wake up. 1 meter cubed is 1 million centimeters cubed, right? Right? So I have 344.25 meters. I need to convert it to centimeters. So I have 344.25 meters, and I want centimeters. So I have to multiply it by how much? 1 million. meters times 1 million. Now, you guys remember grade 6 math. 6 zeros means the decimal moves how many places? 6 places, right? What goes in the holes? Zeros. So I'm going to move 6 places. 344. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 zeros. That's how many centimeters cubed I have, yes? 1 liter is 1,000. So what do I do with that? Divide by 1,000. Dividing by 1,000 gets rid of how many zeros? 3. Gone. So I need 344,250 liters. Once again, was any of the math difficult? It's all conversions, right?
We could have added zeros. You lied to us. Come on.
You were putting zeros in the middle, Emma.
Yeah, you were a little wrong. You could have put the math yet.
Zeros in the middle are not allowed. That would make metric as stupid as imperial.
Well, you told us we couldn't add zeros. You didn't say where. Maybe
All right. This is a trick question. I'm filling the net, yes? So is it volume or is it surface area? It's volume, isn't it? So, if you find the volume of the net and you find the volume of a puck and divide, you should get the right answer, yes? Does that make sense? The net is a rectangular prism. It's 1 deep, 1.22 wide, and 1.83 tall. Does everybody agree that that's the net? Everybody's cool with that? How would I find the volume of the net? Length times width times height, right? It's a rectangular prism, yeah? Now the puck has a volume too, right? So if I take the volume of the net and divide it by the volume of a puck, that should give me how many pucks fit in the net, yes? Makes perfect sense, doesn't it? Except what? Jordan. What shape's a puck? It's a cylinder, right? So if I stack pucks, what is happening right there? There's empty space, isn't there? So can you do volume and volume? No. You have to figure out how many pucks you can fit across. Then how many pucks you can fit up. Then how many pucks you can fit depth. Then you multiply. Does everybody understand? So, if the net is 122 centimeters across and pucks are 7.62 centimeters across, I can fit that many pucks across the front of the net, can't I? How many is that? It's going to give me a number, isn't it? Right? What about this way? It's 100 centimeters divided by how much? 7.62. Because the pucks are the same distance going this way, aren't they? Up and down is 183 divided by what? 2.54. Now I know how many pucks I can get across, how many pucks I can get deep, and how many pucks I can get tall. That gives me a block of pucks, yes? So what do I do with those three answers? That's the length and width and height. And it's something like 14,698 or something. 976. Again, complicated math? No, you just had to think about it. Soup. Where's the paper go on a can of soup? Around here, right? So is it surface area, Anna and Joe, or is it volume? It's surface area. Is it the whole surface area? No. It's only the 2 pi RH part, yes? Because we don't put any paper on the top and bottom. So it's 2 pi times 4.25 times 12, yes? That's 1 can. Times how many cans? 100,000 of them. Multiply, because 1 can is this, but we make 100,000 of them. And that gives you an answer of what? Did anybody get to this question? It's a giant number, isn't it? Right? It's 32,044,245 centimeters squared. Now, is that an okay answer? Yeah, of course it is. Is it an easy answer to work with? No, because the numbers are gigantic. Go sit down in your desks and stop touching stuff. Do frickin' math. It's math class. I let you be over there for the entire time of this. So far, you've bothered me like 5 times. I'll give you another chance tomorrow. These are centimeters. They're a tough number to work with because it's so big, yes? What's a better number to work with when they get big? Meters squared, right? 1 meter is how big? 1 meter, 1 meter. How many centimeters? 100. How many centimeters? 100. So this is 10,000, yes? So if I divide that by 10,000, I'm going to get meters, aren't I? How many decimal places do I get to move when there's 4 zeros? 4. 1, 2, 3, 4. 3,204 meters squared. Everybody cool? Now, the next question was, I'm going to wallpaper my room with these. Is that a real life question? No, it's a stupid math class question, yes? So if I was going to do this, I would need to know how many square meters I have of wall in here, yes? Did any of you measure? No, of course not, because you didn't, right? You're not in trouble, but did anybody measure? So I said to estimate, right? How many meters wide do you think our room is? I know because I just measured it. 20 meters. Exactly my point, Daniel. I need you guys to have an idea of how long a meter is. This is a meter, right? About a step. We talked about this, yeah? It is. It's 8 by 7. Okay? All right. Now, and I said we're going to wallpaper only up to the beam around the ceiling, yes? Which I had to measure because I'm very short. You all laughed at me because I had trouble reaching the tape measure up that high. It was hurtful, but I'm okay with it. I've been short for 40 years. I know I am always going to be short. I'm fine with it. It doesn't cause me any problems, except when I hear that song from the 70s that's called Short People Ain't Got No Reason to Live. Yes, it's an actual song. Short people got no reason to live. Right?
I like it.
I mean, all the tall people in the room, the Roberts, the Daniels, the other Daniel, they're all like, yeah. What are you talking about? But then the short people in the room, like me and the Wyatts, we're like, screw you guys. Huh? No. So anyway, this height up to there was 4 meters. Well, I should have asked you guys for your guess. How tall do you think that is? Pretend I didn't just say it was 4 meters.
4 centimeters.
Oh, 4 centimeters. That's a silly answer, Emma. How tall is it? Anybody want to guess?
4 meters.
Holy crap, that was right on. So, this wall is 8. by what? 4. 32, right? Which means what's that wall?
32.
So what's 32 and 32?
That's like 64.
64. That wall is 7 by 4. So what's that?
28.
What's that?
28.
What's that?
That's like 50.
56. So 56 and 64 is 120, right? So all the walls in our room are 120 meters squared, yes? Are our walls. I have 3,204 meters squared. What do I do with those two numbers? Divide which by which?
Divide the bigger number by the smaller.
Why?
Because we need to find out how long.
Because I need paper is what I have, and I'm covering the walls, right? Paper per walls. And I get 27 times. I could take the factory's paper and wallpaper my walls 27 times. And that's probably as far as anyone's gotten, yes? So page 41 is homework. 41. 4-1. What is happening tomorrow when you get here? On what stuff? On this type of question, which are like, duh, that's mean, or on these type of questions that you can actually figure out. More like this. Okay?
How long is it?
It's a quiz, like 5 questions. But it's not multiple choice, I'll give you that much. It's open-ended the whole way. Okay? No, you don't need to say sorry. Guys, listen to me. That sucks. I get it. Okay? I know we don't like it. But we're all stuck here. Right? So let's do what we can do to keep it as a streamlined as possible. Alright? And chasing each other around like animals is not anywhere near math. Like, it's not even in the same ballpark as math. Right? And sitting over there and talking about them, that's fine. But when I'm explaining stuff, and let's just say, if I'm lucky, there's 30 kids in the room, there might be 15 paying attention. There's 10 that are trying to pay attention that aren't quite capable of paying attention at that time, and there's 5 that couldn't care less. Right? That gives me 30, yeah? Those 15 kids that are paying attention is the biggest chunk of the class, yes? That's who I have to care about. Because I can't care about everybody. You understand what I'm saying? So if you are falling into that 5 that just don't care, for that moment, I'm not saying it's every day you did that, right? But sometimes you just don't care. I get it. Your brain's sort of, I get it. I'm the same way. I go to staff meetings, I take part, attention to part of it, and start talking about something that means nothing to me. And it's like, right? And then they're like, well, weren't you at the staff meeting? Yeah. Right? So I get where you're coming from. Right? But when I'm trying to go to staff meetings and I'm not paying attention, am I doing stuff to take away from the people? I'm just sitting there. That's what I need. You are at that point where you need the wall of your attention span. I get it. It's a long walk. 20 minutes. Class shouldn't be. But you can't get in the way of me of it. Understand? That's what I'm trying to say. I do not want you to lose your personality. I don't want you to change who you are. But I need you to recognize, read the rules, right? Like sometimes when it's time to pay attention and and crap falling and Cleveland and stuff like that really distracts you. I try to give you at least half an hour of class to do it. Plus all the stories and stuff. About that, right? You get enough time for it. So you just try to use the time when you don't have to do math wisely. Okay? That's all I'm asking. Right? And the next thing you need to know is I've taught you one of these before. If you continue to get in trouble, you're going to start thinking that I have some sort of vendetta against you. I do not. Tomorrow is a new day. Alright? Every time. Doesn't matter. Alright? So if something goes haywire and the class goes sideways, you end up with, you end up having to stay with it. It will not be what you dream, because every day you get a new day. Understand? Okay? Because I don't look back. Looking backwards is stupid. Right? Right? Yes!